to be a very informal talk on the progress that we are currently doing on LabMate. And before going into the technical details, I want to briefly sketch why this thing actually turns out to be more sensible than I initially thought. And what's the whole point of adding stuff to Matlab specifically? And I think that there is a bit of selection bias here, namely the people writing Matlab write that in a very peculiar and idiosyncratic way. So it's not just a general programming language, it's programming language that engineers use. And there, a lot of the software actually doesn't just reside in the domain of, like, say, a lot of the variables are not in some simple domain. They're actually dimensions and units attached to them. And there are certain practices when writing such software. So there are good practices, and namely, you can okay, so I cannot really but essentially you can meticulously document any kind of input and maintain in your comment some kind of invariant what is going on. And this will allow to keep your sanity. And there are certain bad practices which are not so rare, unfortunately. What I mean by bad practices is essentially just write a lot of code, have some absolutely bonkers multiplication that no one knows why that is happening, then call a function that supposedly calculates something, and then very casually just randomly factor the matrices by some algorithms. So in this particular example, I think it's because we are scaling down to decibels. So this is logarithmic scale. But what you see is that it's just some absolutely magic random constants.
Like the warning of do something weird. Warning back on.
And this bit of code is actually something that's being deployed. And it didn't really work very well for obvious reasons.
Is this MPL code or is it?
No, it's not MPL code because it's not MPL code because I cannot show MPL code, right?
This is representative of MPL code.
No, the first bit was representative of MPL code. So the good practices of documenting every single variable was what MPL people.
Is this for the engineering?
Yes.
Is this right?
Yes.
Yeah.
Right.
Indeed. Okay, so now that we've established that there is some certain structure that actually makes a lot of sense in the domain that Matlab is predominantly used, what can we do about that? Well, we can try to reify that structure in some sort of formal language of comments. And LabMate is our attempt to actually develop that formal language of comments. So these are Matlab comments. A crucial point here is that we don't really want to develop something that is different from Matlab. We want as seamless integration as possible. So we are going to have a preprocessor of certain comments that we designate as directives. So these are the inputs to LabMate, and LabMate would produce certain responses to these specific inputs. So what kind of different inputs is such processor very amenable to? What is good to support? Well, we can have some systematic transformation of the code. So think very simple stuff like rename. We can have generation of boilerplate based on some a bit more formal metadata specified in the comments. And we can also the point of this talk, use types to actually document what is going on. So that was the brief introduction. And now the way I want to structure the talk is that, okay, we've established our goal that it is to add types to Matlab. So what do we have to do now? And there are certain obvious steps that we are going to be taking. One is, okay, we're going to parse Matlab source code. And this parsing is going to be in very plain old data type, so nothing really fancy. Any kind of trickery is delayed until the operation. After parsing that, we are going to develop some internal term representation for the terms in LabMate. And this is going to be well scoped. We are going to develop a type checker for that. And finally, the crucial step that actually bridges everything together is we are going to elaborate the Matlab code into internal LabMate terms that we're going to type check. And now it's just going to be a tour over different excerpts from the source code. So starting with parsing, and I'm including that mainly for self-containment. There isn't anything very interesting here, besides that we have to maintain a parsing context that differentiates between whether we are in a matrix mode or in command mode. What that means is that, well, Matlab is slightly peculiar. That is, this and this are different, and I really would like to increase the font here, but I don't know how. And this and these are also different. So on the first line, on the highlighted line, what we have is matrix mode that actually changes the parsing once we are inside a matrix. On the second line, we have this very ultra imperative feature of having commands. So instead of calling regular functions, we can drop the brackets and pretend that this is a command. So in the first case, we are calling that command with 2 arguments, 2 and plus 2. In the second, it's 1 and 4. So all these idiosyncrasies of Matlab parsing had to be discovered a bit of by trial and error. And this is what we...
So, Georgi, maybe for the first one, you should point out that in Matlab, there is no such thing as a scalar, right?
Yes.
Scalar is a 1-by-1 matrix.
Yes. So indeed, scalars are 1-by-1 matrices. So any integer you see is actually 1-by-1 matrix.
So the first x equals something is still producing a 1-by-1 matrix. It just passes differently in the second text.
Well, the second text is not producing 1-by-1.
The 2-by-1, right?
Okay, so with parsing then, let's actually move to what we did for the internal term representation. And maybe unsurprisingly, we are using Code Brown. And maybe again, unsurprisingly, the terms are very much geared to bidirectional type checking. So we are having seen and check. But instead of going for mutual inductive definitions, we've wrote that into one.
There's not that one static type system itself.
No.
There's no type system into there. All the typing you're doing is stuff you say that.
Yeah.
I mean, it has a dynamic type system.
Right.
Yeah, but so far we are not actually interacting with it, and we are not
No, but it's
querying
not-
it for.
It's an obligation for us to agree with it, right?
Yeah, but
Or is it fair to sort of say that what you're doing is you're retrofitting a new type system to Matlab?
oh, what do you mean by that, though?
So retrofitting,
So
you've got your existing term language, right, that you're working with, and you're saying, right, screw the existing type system, be it dynamic, whatever, and say, like, here's this new one that's right on top of it, but doesn't.
no, what I actually meant is that we're indeed retrofitting a time system on top of that, but it's fully optional, right? So
Yeah.
there is no way to actually enforce anything. And we are not going to generate any kind of runtime MATLAB warnings that something's wrong. So our terms are indexed by the scope, so the variable support, and by the source, where the source is actually the data type that tells us whether we are in in checkable or synthesizable fragment. And there's a bit of something more going on, which was an observation that we can actually get away with the substitution constructor if we code the substitution as part of the source. So what we have is synthesizable fragment, checkable fragment, we're closing under products, and then we are adding another source for substitution. Then in order to minimize the actual constructors of the term itself, we have one generic constructor that takes a CTOR and applies it to a term. And then CTOR is actually the family of constructors that we are interested in. And again, there isn't a lot of tricky stuff. We have the usual atoms, literals. We have the embeddings and annotations. So these are the two ones that allow us to switch between the directions. And okay, maybe just again to be self-contained, though judging by the people here, this is completely useless. But what's the whole point of bidirectional type systems is that a regular judgment is split into two, type synthesis and type checking. So we have the checkable version in which everything is input. So the type T and the term T are inputs. And we have also.
Do you want to flip the inside?
Yes. And we have the synthesizable version in which the type T is an output. And this relationship is exactly what is encoded into the indices of our constructors. So for example, the notations called radical hairs get two checkable terms and produce and give us a synthesizable term. With the intuition being that, okay, we can have a term and we can annotate it with some type, but then given that it's pretty clear that we can just read out the type to actually synthesize it and return T here as an output. Then for substitutions, we have two constructors, one for the empty substitution and one for the substitution that sticks a synthesizable term on an existing substitution. So the constructor st is the way that we actually extend substitutions. And then for the constructors of term itself, where we have the usual variable and constructors for lambda function, where because we are coded Brown, we have to differentiate between whether the variable is going to be used or not. We have this generic constructor, and we have the absolute heavy lifting of the whole class, namely the pairing bit, which takes two terms in scope L and R, and also covering. So that is the way that the terms are embedded into the bigger scope N, and in particular, N must be the sum of L plus R, and we give a term that is in the source of the product of A and B. So here we are really just pairing up, and we are using all the variables in scope. And we have to say how this scope is actually divided into L and R. Another important constructor that I just skipped over, but again, I guess this doesn't come as a surprise, is the meta variable one, where by meta variable we mean real unknowns that we solve during the constant solving, and not really some kind of like schematic variables. Okay, so this is very much Lispy syntax. What are we going to do with it? Well, we are going to build the type system on top of it by essentially tagging a lot of pairs. So our types are going to be some specific atom, a tag, and then whatever the type requires. So let's see some of the types. And we'll pay a bit more special attention to three of them. So we have the usual unit type, atoms, types, characters, etc. But then we have three abelian groups and three monomers. And these are over an arbitrary set of generator types. And we also have a matrix type. Okay, so what exactly is this weird looking matrix type? So the whole idea behind it is that we are going to have headers, so row headers and column headers, which are going to correspond to RC and CS here. And then the row headers live over some free structure, free monoid or free abelian group, over the generator type row T. And the column headers live over the generator type code T.
Yeah, that's flipped. You.
Oh yeah, yeah, yep. Obviously, yes.
think it's useful.
It's easier to transpose to the market.
The RS has type 3 group on birds.
RS is a list of those type.
I mean, it really, I think we have the optimization where if rota is a proposition of we indeed go to a billion groups.
Yeah, so if it's a list of a unit, then
Yeah.
that's the only thing that matters is the length.
Yeah,
And the representing just as the three group components. You see it.
Right, if RS was.
Could be
So
yeah, could be some would be less.
just this.
and then cell type is giving the type of elements in the matrix. So this must be under binders for the row and the column.
Very fine, so it's fine.
Find those the info. Under R, which is the row type, C, which is row type. And then you see the lists of the prospects.
Okay, yeah, so how do we actually check that a matrix type is well formed? We are going to want to peel that cell type is indeed under, like a pi type under the row and column type. Check that the row and column types are valid types themselves. Check that cell type is valid type under.
Back on.
See?
Yeah.
And finally call check. So we are going to be type checking no longer the types themselves, but RS and CS that they're inhabiting the list of row type and the list with generator column type. Okay, and there's another bit more interesting type here, and maybe you can see where this is going on, but we have nums and we have 3 billion groups, and following, I think, work by Andrew Kennedy, we can model dimensions and units as the 3 billion group over the set of fundamental dimensions. And essentially, we can create atoms for, say, mass, length, and time. We can then create a num type corresponding to that and use that as the generator type for the type Abel. Okay, so these are our types. How do we check that certain values are of these types? And again, I'm going to pay only special attention to billion groups, lists, and matrices. Okay, so maybe let's start first with what is happening with matrices.
Well, really must be. One second.
I think that it is.
Yeah.
Sorry?
Both functions and the
This is because
So maybe version. Maybe.
I mean we cannot really put exclamation mark as
So yeah,
in scheme, right?
Apology. Yeah, Americans like typing, but yes.
Yes, the identifiers are in Australian.
million questions. Oh, this is definitely. And because that's what the main question was.
Yeah, this is trying to do this because of the language, but that's what parser. Yeah.
Okay, so given a matrix type and given some term, how do we actually check that this is a term of that matrix type? Okay, let's actually, I haven't told you, but what are the constructors for matrices? And we have 3 options here. So a constructor for matrix would be a simple embedding. Okay, I shouldn't use the word embedding, but we can construct a matrix with a single cell. And we are going to call that 1, or in the source code also called S1 with small o. Then we can essentially paste, juxtapose horizontally and vertically 2 matrices. Okay, so now let's see how we are going to be checking the terms, with the basic idea being that we have some columns and some rows coming from the matrix type. Then we are going to have some rows and columns coming from the term. And what we want is, we want this difference to be 0 in the end. Okay, how do we determine this C0 and R0? Well, if it's the constructor for single cell, we are just grabbing the first element of the list. And then we are returning the rest of the list. So for a single cell, we are going to return this bit here, these bits here. Let's call them RS1 and CS1, and hope that these are 0 length. Then when we have, say, horizontal juxtaposition, that constructor takes 2 matrices. So say that this is our left matrix, and we have another matrix here. Okay, so of course, in order this to be well defined at all, what do we want? Well, we want the horizontal juxtaposition to make sense only when the height of the matrices, the rows are the same. So we want this bit here to be 0. So this is what we demand with different names. So in the code, this thing is called RS second. And essentially we type check the first matrix and we return this corner here and this corner here. And then we type check the second matrix corresponding to the top right corner, demanding that the difference here is 0. And finally, what we return is the corner composed by the column of the two matrices in this top right corner coming from the second matrix. And then we are going again to demand that these things are, this bit here is 0 and this bit here is also 0. Okay.
These kind of juxtapositions look in the source code. So naively, I thought the matrix would be a list of rows, which is each row is a list of columns.
So
Then you could just sort of march down each one, check them off. Rather than having this tiling where you're not actually deciding that. So is that something in Matlab or you can make? I was wondering how, where the hijux and widgets come from the source code. So how would you write to Matlab source code that generates?
oh, okay.
Because naively, I would have thought a matrix in source code would be parsed that has a list of rows, each one is a list of columns.
Yes.
And then you just match that list against the columns. List of rows against rows.
Yeah, but I think that this is the bit of elaboration that we have to employ to translate from the MATLAB source code or our internal representation into this kind of building blocks.
But when you write a matrix in MATLAB with the square bracket notation, the things that the entries that you put in that matrix are allowed themselves to be matrices.
Okay. And then also
That's to say, MATLAB builds matrices by tiling.
right.
So in fact, they are always matrices. Just some of them are matrices.
So if you less square brackets, then really that just gets flattened down.
But it might be easier to explain the algorithm in more direct style, where you're splitting explicitly on the R's or the C's, depending on whether you have a vertical or a horizontal split. And then say that the implementation is basically the CPS version of that. If you don't do the split ahead of time, because you don't want to.
Accidental recursive definition.
Anyway.
It's dependent on the variable itself as a matrix. So you could have a 1 by 5 matrix at the top and 5 underneath and down here.
You can't have a matrix.
Absolutely.
Everything is always
Makes sense to me about how that's going to be the efficient matrix.
Okay, maybe since we are talking about matrices, let's quickly glance over how we can normalize in this representation. So the idea is that we are going to represent a matrix in normal form as a stack of rows or a column of rows, and for which row we are going to remember the height.
So Matlab really is a two-dimensional DSL.
And what each row will consist of? Well, it will consist of matrix-like things with the same height, where the matrix-like things are going to be either neutral elements, or single cells, or other matrices. Okay, so then the question is, if we have, what do we do with the vertical and horizontal juxtapositions in each case? Well, one we get for free, so we can just paste vertically and that's it. We don't have to do any adjustments. But what about the horizontal one? So what we have to do here is find the first row. So first we have to pre-process, and actually let's do accumulation of the row height. So instead of tracking only the heights of specific rows, let's actually accumulate them starting from the top. Okay, so
Is it because of which one?
Like square ones. So if you want to do the identity matrix, you could do, let's say we have the 0, 0, 1, 9. No, you might not find out.
okay, so when we accumulate them, what we then do is try to find if we can take a single row with height 2 from the matrix on the right. Not really. So we start by taking the first single row from the matrix on the left, try to see if we can find something with the similar height on the right. Not really. Then we take the first 2 rows and try to see if we can chop something of height 5. We cannot. But when we eventually find the right stack of rows from the left-hand side that has height that is found in this accumulative list on the right-hand side, we take these rows and we can now paste them together horizontally.
In the worst case, I have to take the whole.
Yes, but we always know that these have the same height, so this will eventually terminate. And now, depending on what is actually in the rows, I mean, we might have to tag it additionally, right? So if we have like a single row on the left and right, we can just directly concatenate them. Otherwise, we have to make them matrices, like make them matrix-like using the NF compound tag. So for example, here, in order this bit to actually be pastable together, we are first going to squeeze this and then paste them. Finally, the normal form itself is just imposing a structure. So we are going to say that it is always going to be a vertical juxtaposition of horizontal juxtapositions. Of neutrals or 1-by-1 cells. Okay, so this is how we can normalize matrices. What about normalization of lists and abelian groups? So for the abelian groups, we used like a cheap trick, namely the data type for terms was ORT, so we can actually sort our terms. So then an element of an abelian group is in a normal form, is a pair that counts the number of news in the generator type. So if the generator type admits a new element, we are going to count them, or we are going to maintain a list of the terms with their multiplicities.
The middle thing is just optimization.
Sorry?
The NF const is just optimization.
So yes, the NF const is also something that if we have an integer and we have like a lump of syntax that is tagged as an int, and we want to interpret it as an element of a abelian group, we are just going to populate indeed NF const. But also mind you that because of the invertible elements, so I might be negative, right?
No, if NF const was known, then one of the elements that are stuck would be first. Well, would be there. And I thought it was just an optimization, so it didn't have to represent middle to the array.
Yeah.
As one of the things in NF stuck, it's just represented as an image.
You have 2 on one side and 1 plus 1 on the other side. And 1 plus 1 is confused. So that you can see that as in 1. We have 1 plus x plus 1 plus 1. Instead of to suit terms, because 9 1 and 1 and 2 ones. I think which is damage.
No, because that really easy.
Both the x and the 2. Yeah, in this representation, not if you do that of course. Separate.
Get actual man.
Right, what you do with for instance.
Yeah, it's usually. You got
Yeah, it's not.
But just to recall, or actually mention for the first time, which bits of syntax are admissible as the elements of the abelian group. So integers that actually employ the NF const. Then the new element is just the neutral element of the group. Then we can embed an element of the generator type using, okay, not embed, constrict an element from the generator type using the one constructor. And then we have the group operation for elements, two elements of the group type itself, or the version where we pair the multiplicity of an element of the group.
The integers are being improved. It's not just the
Yeah, I mean, they're not.
So we have three reading groups and integers. There's two different elements of the group of integers are the three reading group of optimization, which is good. That's two ways. But one is that it takes integer constants and automatically makes them into units to the eye.
Yeah.
Okay, so using kind of stuck.
Integers to and also it's optimization, because otherwise it would have units of the eye and then have stuff.
Yes. And we have similar situation to lists there.
Does not have lists distinct from
Distinct from matrices, like from vectors. Was that the question? Sorry.
Does it have lists that can be arbitrary type? That are not.
Not really, I would say.
This is just for you.
They're cell types, right?
Yes.
It's not really a list type.
Yes. I mean, they can have like lists of function handles, weird stuff like that.
Yeah, but that's a cell.
Yes.
It's more of an array than.
Maybe the just for the inputs. So they're not part of it.
Right, and that made just.
Okay, but to speed up, essentially the situation with this is roughly the same, where for this we kind of have to differentiate between whether we have a real element or something that's stuck, and we just use the either as tags for that. So then integers can be a list of new elements that are not stuck.
You check if I is positive.
If
I is positive.
we do check at some point.
Oh, this is the type check.
Yes, I think we are assuming the term type checks, right, before we use this function.
Yes, this is not really the function that type checks. This is part of the.
Yes, it seems the type is correct, so it's correct, but type checks. So I guess I wouldn't touch it.
So at some point we do type check whether we have negative lists. I mean, at some point in the type checker. Okay, so then we essentially evaporate Matlab to this term representation and try to run the type checker. And because it's 12, I'm going to very briefly go to that. And so this is where we roughly are. And we have a zipper-based virtual machine that creates frames from the target of our MATLAB parsing, then creates the meta variables for the variables in MATLAB and tries to solve them. And so far, the constraint solver isn't really very advanced.
Maybe you could show this a bit slower. Maybe delete most of the directives. Delete the first line.
I can also maybe show traces.
Because I think you were running LabMate, right? But it looked very similar to you undoing the delete you just did.
Ah, you think I'm cheating? So
So maybe delete the first line.
yes, okay,
And
let's
delete the response, and maybe put them in the.
Well,
Well, okay, we can start like this.
yes. So let's see whether we can deduce anything. And we cannot. So we don't have any defaulting rows. And again, the type of n here is going to be 1 by 1 matrix. So essentially, it's going to be a matrix where the row and column type are 1, cell type again 1.
So really, one by one matrix.
And if we annotate that with int, and let's maybe run it with the output of them.
Let's see the noise.
We get back that we have made our way through all these assignments.
So if you put like a matrix, so you said n is a 2 by 4 matrix. No, because that is 1.
Yeah.
So right now we are not really handling a lot of matrix multiplication.
I just mean if you said n was something is you said that it's 2 by 2.
Okay, we also are not elaborating very much.
And in this part, we should run in the terminals, we can get the whole message.
Or we should say n. It's like I was with everything right.
See, maybe it's just.
Oh, did I change something?
But we can check out.
Yeah, it should.
It's a bit later, but I guess you could have guessed that. You have a lab that is capable.
Yeah, I would just. Just assign.
Oh, wow.
You can do it.
But we can see in the beginning of the store right now that we are indeed just taking your words for it. That this is 3x2 matrix.
I think what's going on is that we don't know a different type for X, right? So we're not ready to say this is the wrong type. This is not
So if it failed with your sign 5 to 10, because that's not a three-way matrix.
So I think it's the same one. We don't know the type of phi.
It's definitely not.
It's not, yeah, we should check. We know that it's 1x1 something.
Yeah. Unless
So-
you can expand it. I don't do that.
We may not have some.
So they this, you scale them.
This was what we're at passing zeros.
So I think right now we are actually struggling a lot with any kind of overloading and trying to figure out.
So could be right, take the 5 on the source code.
In the original Matlab.
No.
Because it's in your lesson.
No, Matlab only line is.
So it actually really goes quite haywire for matrix multiplication because I mean everything is matrices in our representation, but obviously we want to be able to scale on the left and the right with a scalar. So we want to allow
You scale it times matrix. So it does do it.
so
There is no difference, just the sum of the allows to multiply 1 by 1 matrix. Yeah, and by this.
So morally, there is where scalars and matrices there are different treatment methods. So that's not most of the website. It's with some special source for where some.
Various context.
Weird qualifications of the.
So essentially, when we see some kind of matrix multiplication and we don't know anything, we are not given the notation for one of the multiplicants, we have to generate all 3 possibilities, right? Where we have 1 by 1 on the left, 1 by 1 on the right, or where we actually have matching rows and column in the middle. And then there's also the issue that what are meaningful types that admit multiplication, and can we actually get some kind of unique representation? So and I think this is the last bit here, but if we have So are these the same what to do about it? And say that this is under binders X and Y. So if we so under what conditions the types for rows and columns and the cell types are actually make sense to be multiplied together. And that's pretty much where we are and where we hope to continue next time. And I think since I'm also quite overrunning on time, we'll close on that. So I think it's actually cool stuff is happening and there's a lot of stuff to be done about it.
What's the status of the project and the future development? Is this we found it interesting problem, but now that's good time. I mean, this sounds really cool, right? And the tools design could be really useful for purposes. Is there funding and time available to actually continue it? So it will be sort of your average music.
I guess there soon would be news about whether there is time about it.
So apparently we have a meeting Tuesday about an extension from them, which, as I understand, it won't pay us anymore, but it would let them still spend time on talking to us.
In terms of, so.
Georgi Nakov.
Yeah,
But
I mean, like this got a long way.
yeah,
And with a bit of extra.
which is why we want another.
Yeah.
you know, also this MPL is really interesting thing too. I mean, they really don't care that much about the cool type here, you know.
Is the backward?
Yeah.
I mean, as far as the way Matlab is kind of like, so they can potentially be.
Yeah, it's used in like defense industry, electronics industry.
Yeah. It's either money or
All safety, right?
I don't think it's a lawsuit. I mean, they could have us solve. That's what this was my question. It's been, I guess, something that's the part of the challenge, and then that's the answer in Matlab and what Matlab's doing.
Sorry, could you repeat it a bit louder?
So what's been the sort of major challenges from? And I can say that sort of anticipating the answer in Matlab except for box.
I mean, yeah, pretty much trying to see how MATLAB works and what is admissible syntax and how it's actually interpreted there is.
So is that just because they haven't written down for the so.
I mean, there is no formal spec. The closest that is some kind of grammar for highlighting mat code.
So is the language definition required?
There is no language.
There's a compiler you can find.
Right, because I was just thinking of the situation that you have with the system variable. So the language is standardized, but you can have different compilers. So while people's compilers might be black box, the language and what the compilers support might be different, but the language itself has been standardized.
I mean, we didn't, at least I didn't find reference and I was searching for
So
them.
this is for your help story.
Yeah.
One vendor. Yeah, right, language, like Excel.
Yeah.
They have one documentation.
But it's not.
Thanks.
Okay. It's not 100%.
But it's subset.
But I think the value proposition of MATLAB is there are libraries for whatever thing you want to do, right? Just like that. A great fortune.
Yeah.
Value proposition is that's for which is
Matlab comes with binding and runtime for a lot of languages. Okay, at least Python for sure.
I know there's companies in Edinburgh that are using support computers without like MATLAB.
This is what I mean, like, there's like loads of people using it. And stuff and answers to design, I think, are good stuff and answers to design. You sort of have to find a project which has enough sample code to protect the answers. Also, that's the thing.
Yeah, I could
I wonder if some kind of impact accelerator. They want me to continue with it.
I imagine Leonardo,
Yeah,
because there's a lot of work in digital twins. That some of that is data they're collecting, you know, is they use MATLAB for analysis. Heavily. You know, make sure that analysis is correct as a critical infrastructure. Well, infrastructure.
All right, well, my laptop is about to die, so let's thank Georgi again and close this meeting.
Sorry.